Hello everyone, I'm Lanqing from Shanghai Jiao University, and our co-authors include Xinqi, Xiangyong, Leping, Yijie, and Qianfei, and my tutor Yi-Chao, Chen, Guangtao, in Shanghai Jiao University, and our co-authors also include Professor Xiaoyu at Zhejiang University. It's my great honor to be here to present our work, Remote Attacks on Speech Recognition Systems using Sound from Power Supply. We are very familiar with speech recognition systems in our life. These systems can translate spoken languages into text and execute the corresponding commands. And there are many devices using SR systems. For example, the voice assistants in smartphones and smart speakers, the smart appliances, or the vehicles. With these SR systems, we can easily read the messages or making phone calls or manage our smart appliance easily anytime and everywhere. So once these SR systems are attacked, they may bring many security concerns. For example, if the hacker pretends to be the owner of the device, they can command the voice assistants to open the door of our home, or to make phone calls directly to the hacker and to record our private conversations. So all this bring security concerns to our life or our privacy. And existing attacks can be classified into the short-range attacks and the long-range attacks. For short-range attacks, the attacker approaches the victim and plays the modulated sounds. These sounds can be modulated into ultrasonics that we can't hear. For example, the dolphin attack. Or they can be modulated into the hidden noises that we can't understand. These noises are usually generated with deep learning. However, these attacks often require very near access to victim, which limits their attacking scenarios. And there are also existing remote attacks on SR systems. For example, some use the laser or the speaker array to directly aim at the victim and play the modulated light or the attacking sounds. However, this attacking requires line of sight or specialized devices such as the speaker array or the laser. And there are other attacking that they use the spy instead. For example, they don't directly attack the victims, and they assume that there is an always-on TV or a radio to receive the attacking signals and to play the attacking sounds to a nearby victim for the attacking. However, this method also requires an always-on radio receiver on targeted channel. So all these methods require uncommon devices or specific scenarios. So this is the question: how to break these limitations, such as the limited range, the use of uncommon devices, or work under certain conditions? And our answer is to use the easily accessible device, the power supply, for a remote attack. And this is the power supply. We know that most electrical devices use the power supply to maintain a steady voltage. These power supplies can be both inside the device or outside the device. And we may have experienced that some power supplies can generate sound when they are working. For example, in this radio. Oh, I'm not sure whether you can hear that. Oh, okay, thank you. This is the sound from a lamp's power supply. We can also see that when we change its working state, it can generate sound of different frequencies, the right figure. So how about use this sound for a remote attack on the SR systems? Before we can make it, we need to answer the 3 essential questions. Question 1, why power supply generates sounds? Question 2, can power supply these sounds be modulated? And question 3, can these sounds be modulated remotely? These 3 questions. For question 1, why power supply generates sound? Look at this power supply. It's the switching mode power supply. In fact, almost all the power supplies we see in life is the switching mode power supply. The name is because that when it works, it turns the switching transistors on and off frequently. When the transistor is on, it charges the capacitor. When it's off, it charges the appliance. We can see that the current direction is different. So we can conclude that when the power supply works, it can generate current changes in its power supply, in the circuit. And then, because of the oscillator effect, the current changes also cause the electrical magnetic field changes at the same time. And note that there are many small components inside the power supply. For example, the inductor. Because of the magnetical subtractive effects, these inductors can deform or vibrate and the electrical magnetic field changes. And similarly is the capacitors. Because of the piezoelectric effect, these capacitors can also deform or vibrate. So all these components, the deformation or the vibration, they cause the power supply to generate sound. And this, we can answer the question 1. For question 2, can power supply sound be modulated? Our answer is also yes. Take the laptop, for example. This is the power supply. If we change its CPU, it can directly cause current changes in the power grid and at the power supply. So it can drive the power supply to generate sound. For example, in this figure, if we control the CPU to switch at a frequency of 70 Hz, we can also notice a 70 Hz sound at the power supply. Not only the switch frequency, in fact, when we control the cores, the CPU modulation used, all the duty cycles, the durations, the running instructions, the load, and the multiple computer CPUs, we can both generate different sounds, and all these modulation can be used for generate a sound as a power supply. This is question 2. Question 3, can this sound be remotely controlled? Our answer is yes. Take the attacker and victim, for example. In this picture, they are connected to the same distribution box, and their topological map can be simplified as this. We can know that the attacker's current I0 and the victim's current IR, they have a relationship in this formula, which means that if we modulate the attacker's current, it can also cause changes to the victim's current, and then the current changes can drive the victim's power supply to generate corresponding sounds. So this is the question 3. Within the same distribution box, the power supply's sounds can be controlled remotely. And based on these questions and answers, we built the attacking system. This is our threat model. We assume that, firstly, the attacker and victim are connected into the same distribution box. It means that for the same distribution box, it can be different rooms in a building. If the different floors of a building, they use the same distribution box, then our attack can attack across different floors. And secondly, there is power supply near the victim to generate sound, so that the SR systems of the victim can hear it and recognize for attacking. For example, LAMP's power supply, we have a scenario that when the user is at home, his phone is left near a lamp. Then the lamp's power supply can generate sound for attacking. And thirdly, the victim device is left alone so that the attacking will not be noticed. And this is the experiment set up. The attacker is the desktops, and the victim is the smart speakers or cell phones. And we assume that there is a power supply near the victim. Okay. This is the generated sounds by our system. The left is the Hey Google, call my mom is human voice. The right is our generated sounds. These experiments results show that using one desktop, we can achieve an average of success rate of 75% across the 10 SR systems. If we increase the desktop used for attacking, we can increase the success rate to 100%. As for the attacking distance for one desktop, it's about 2 meters, but for the 4 desktops, it's 23 meters. And as for the modulation scheme, we then evaluate the efficiency of the proposed modulation schemes. We compared our scheme with, for example, use the switch frequency only and others, and we found that our modulation general sounds are more human-like and can achieve a more can achieve a distance of more than 2 meters. This is a demo. Yeah, they are at different rooms. And this, okay. In this demo, we control the Google Assistant to make phone calls to the hacker directly.
Calling hacker, mobile.
Okay, so there are some takeaways. We proposed a remote attacking scheme using easily accessible power supply. We investigate the reason why a power supply is suitable for this attack, and we proposed a fine-grained modulation scheme using different modulation schemes and methods. That's all. Thank you. I'd like to take any questions.